In the world of software development, there is a constant tension between speed and safety. We want our code to be written quickly by intelligent systems, but we also need to know that it will not fail when it matters most. This is the core challenge facing the industry today. Large language models can generate code in seconds, but they also hallucinate. They invent functions that do not exist and overlook critical security flaws. For a long time, we accepted this risk as the cost of automation. But a new paradigm is emerging that promises to change the rules entirely. We are talking about the fusion of large language models with formal methods, often discussed under the vision of agents like Leanstral. This is not just about writing code faster, it is about writing code that is mathematically proven to be correct. To understand why this matters, we have to look at how we build complex systems. Consider a machine learning inference pipeline. This is the part of a system where trained models make predictions on real data. In a high-stakes environment like autonomous driving or medical diagnostics, a bug in the memory management or a violation of a safety invariant can have catastrophic consequences. Traditional testing can only show the presence of bugs, not their absence. You can run 1,000,000 test cases and still miss the one edge case that causes a crash. Formal verification changes this game. It uses mathematical logic to prove that the code adheres to specific properties under all possible conditions. The problem has always been that formal verification is difficult. It requires deep expertise in logic and languages like Lean. Most developers do not have that background. This is where the concept of Leanstral becomes relevant. It represents a shift from general-purpose coding agents to specialized formal proof assistants. Instead of relying on heuristic vibe coding, these systems prioritize mathematical verifiability. They bridge the gap between theoretical correctness and production reliability. The foundation for this work is often built on Lean 4, a programming language designed for writing formal proofs. When we talk about using Leanstral to write formal specifications, we are talking about an agent that can translate high-level requirements into precise mathematical statements that Lean 4 can check. Let us walk through how this process works for a machine learning inference pipeline. Imagine you need to ensure that a specific function handling user input never reads outside the bounds of a memory buffer. In traditional development, you would write the code and then write unit tests to try and break it. With a formal agent, you start by stating the invariant. You tell the system for all inputs, the memory access must be within the allocated range. The agent then generates the code and, crucially, the proof that this code satisfies the invariant. If the code violates the rule, the system flags it before it is ever compiled. This moves the verification from an empirical check to an algorithmic guarantee. The technology that makes this possible involves a sophisticated ecosystem of tools. Research into this field points to projects like LeanAgent and CSLib as the building blocks of this vision. LeanAgent demonstrates significant success by proving theorems across diverse repositories. It uses a lifelong learning framework, which means it does not just solve one problem and forget it. It builds a dynamic knowledge base that grows over time. This addresses a major limitation in current AI. Models often suffer from catastrophic forgetting, where learning new information causes them to lose old knowledge. A formal proof agent needs to remember thousands of mathematical lemmas and previously proven theorems to construct new proofs efficiently. Consider the analogy of a master carpenter. A novice carpenter measures twice and cuts once, relying on their immediate knowledge. A master carpenter has a library of techniques and tools they have refined over decades. They know exactly how different materials behave under stress. Formal proof agents aim to be the master carpenters of software. They do not just guess at the solution. They consult a library of verified mathematical truths to construct their arguments. When an agent encounters a new problem in the ML pipeline, it retrieves relevant proofs from its knowledge base. It combines these known truths to build a new proof for the specific safety invariant you need. This approach signals a broader industry trend. We are moving away from proprietary black box coding tools toward community-driven, transparent verification ecosystems. In a black box system, you trust the vendor that their code is safe. In a formal verification system, you trust the math. The code is correct because the logic holds up under scrutiny. This is particularly important for open source initiatives. When the code and the proofs are open, the community can audit the verification process. This creates a level of trust that is difficult to achieve with closed-source AI models. The development of these agents also requires a shift in how we think about the learning process. The research highlights that current systems are capable of proving hundreds of theorems across different repositories. This suggests that the learning curve for formal verification is becoming more accessible. The agents are not just static models. They are dynamic systems that can generalize across expanding mathematical libraries. This means that as the library of computer science concepts grows, the agent becomes more capable, not less. It can handle more complex invariants and more sophisticated proofs without requiring a human expert to rewrite the entire verification strategy. However, this is still an emerging field. The specific entity known as Leanstral is often seen as a conflation of these separate initiatives like LeanAgent and CSLib. It represents the ideal convergence where an agent can autonomously handle the full life cycle of formal verification. It can take a requirement, write the specification, generate the code, and prove the safety invariants all within a single workflow. This is the future of trustworthy AI agents. It is a future where the hallucination problem is solved not by better prompting, but by better mathematics. We are seeing the early stages of this transition now. The fusion of large language models and formal methods is being proposed as a unified roadmap for trustworthy AI. The goal is to overcome the limitations of current generative models by grounding their output in rigorous logic. This does not mean we abandon the generative capabilities of AI. It means we use them to handle the complexity of the proof construction, while the logic engine handles the validation. This combination leverages the best of both worlds, the creativity and speed of the model and the reliability of the formal system. As we look toward the future of software engineering, the distinction between writing code and proving code will blur. The tools we use will not just ask us to write functions. They will ask us to define the properties those functions must satisfy. The agent will then do the heavy lifting of ensuring those properties hold true. This shift changes the role of the engineer. We become less like bricklayers laying individual lines of code and more like architects defining the structural integrity of the entire building. The agent handles the construction, but the architect defines the safety standards. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.